on to the next part of this chapter, which is on quadratic inequalities. Now, the way we need to solve these is to sketch them. Do not try to solve these without sketching it. You'll be tempted to, you'll want to, don't do it. Do not do it. Always sketch the graphs, the quadratic curve, when you're trying to solve quadratic inequalities. Don't like this, negative 2x squared. That's going to be an unhappy graph. Don't like unhappy graphs, I want things to be positive. So first thing I'm going to do is smack everything onto the other side. So I'm going to get 0 is greater than 2x squared plus 5x minus 3. So as they move sides, all the signs change. So I know it's going to be a happy quadratic. I know it's going to go through the y-axis at minus 3. Could do with working out where it crosses the x-axis if it was equal to 0. So to do that, factorise. So it's got to be 2x and x. The only way of making this a minus is if one's plus, one's minus, and they've got to multiply together to make minus 3, and then combine together to give you 5. Well, 3 times 2 is 6, take away 1 is 5, let's try that. 6x, take 1x is 5x, minus 3, bingo. So the critical points, the roots where it crosses the x-axis are going to be a half and minus 3. What I'm looking for is when the graph is less than 0, actually here, when the graph is greater than 0. Look, it points away. This is the one I've drawn, not the original graph, not the original equation, the one I've drawn. Look, it points away from the x squared, it points away from the x squared. I want when the graph, the curve is bigger than 0. This is looking at the x-axis, when it's above the x-axis. So it's above the x-axis here. So when x is bigger than a half, it's above the x-axis here. When x is less than minus 3. But because you've got a gap where you can't be both, you need to use the word or. On to B. Again, you need one of the sides to be 0, and ideally want it to be a positive x squared. That's example 10, sorry. So if I bring those over, I get 0 is greater than x squared minus 4x minus 12. Look, it's pointed towards the x squared, so when the graph is less than 0, below the x-axis, but I want to draw it first. So factorising it, x and x, times together to make minus 12, add together to make minus 4, and it's going to be minus 6 and plus 2. So the critical points where it crosses the x-axis are 6 and minus 2. It's happy. So just do a quick sketch of that. But this time we want when it's less than 0, and that means below the x-axis. That's here. So it's between minus 2 and 6. Or you can write it separately. X is less than 6 and x is greater than minus 2. Either's fine, but you do need to use the word and if you're not combining it. So remember, when you've rearranged it, so you've got a positive x squared and the other side 0. If it's less than 0, you're looking for the section where it's below the x-axis. If it's bigger than 0, you're looking for the sections where it's above the x-axis. That one's you'll need an or. Part B for this wanted the solution to the quadratic we've just solved, and 5x take away 3 is greater than 2. So it's got to be in this region and whatever the solution to this is. So take the minus 3 over, 5x is greater than 5, divide 5, x is greater than 1. Now to this, I'm going to show both of these, all three of them, or the combined one, and this on a single number line. So between minus 2 and 6, was less than or equal to, so empty circles. and x is greater than 1. With nice long lines. And what you're looking for is where you've got both lines. So it's going to be between 1 and 6, or writing it separately, x is bigger than 1 or x is less than 6. Okay, on to example 11. We need to find the values for which 6 over x is greater than 2. Now this is a deceptively difficult question, because the tempting thing to do is bring the x over, divide by 2, and you can have what x is less than 3. But that is incorrect. Or not complete, I should say. Now when you're bringing x over, what you're actually doing is multiplying both sides by x. But x could be negative. We don't know what x is. And if x were to be negative, the inequality must reverse. So we can't do that. So what we have to do, sneakily, is to times both sides by x squared. Now the reason you could times both sides by x squared is because it doesn't matter now whether x was positive or negative. X squared is definitely positive, so the inequality is going to stay the same. So we're going to end up with 6x squared over x is greater than 2x squared. X squared and x just cancel. Give me 6x is greater than 2x squared. Let's bring that over. 0 greater than 2x squared minus 6x. Points towards the x squared. So I'll put the less than 0. Factorise. We'll take 2x out. 2x, and that's going to be x take away 3. Okay, don't be tempted to try to do this without drawing the graph. So we've got critical points of 0 and 3, and I know it's a happy quadratic. Less than 0, below the x-axis. So solution to this problem is anywhere between 0 and 3. So x is between 0 and 3, or if you want to write it separately, x is bigger than 0, and, because it's between, must be both, x is less than 3. Okay, have a go now, exercise 3b.